and thanks for logging on. This is the notes for section 8.5. So our objective in this section is to do some more factoring, but in this section, we're going to do a different kind of factoring. Now, there's many kinds and methods for factoring, but the word itself means to break into multiplication. It can be this type of a problem, where you just look at it and say, you know what, I can pull out an 8 and make it 2 times x squared plus 4. I've taken the polynomial and I broke it into a multiplication problem. In 8.5, what we're going to do is take what we call a trinomial. It's actually a quadratic trinomial, and we are going to break it into a multiplication problem. Right now, it's an addition problem, so we are going to factor it and break it into multiplication. For day 1 here, we're going to keep things kind of easy, and you'll see why it makes it easier as the days progress. We are going to keep this last number here always positive, which is going to make things a little easier today. So our objective is going to be to factor. But before we do that, I want you to recall the FOIL process. FOIL is how we multiply. And it's when we multiply a binomial times a binomial, and we do the firsts, and we say x times x is x squared. And then we do the outside, and we get 7x, and the inside, and we get 3x, giving us basically 7x's and 3x's, or 10x's. And I want you to notice that what's in front of the x is coming from adding 7 and 3 from the outside and the inside. And then our lasts we get by doing 3 times 7. And when I clean that up, I get my firsts, O and I, which combine to make a 10x, and my lasts. Now, our goal today is going to be we will be given this, and we're going to have to basically unfoil or factor it. So a couple little things to notice. First of all, when I say what is the coefficient of x squared, I want to know what's out front of x squared, just so you know. And the answer to that is 1. What is the relationship that you're seeing between this 10 and this 21? And you should notice that the 21 is 7 times 3, whereas the 10 is 7 plus 3. So we should note that 21 is 7 times 3, and the 10 is what we get when we add those same two numbers. Why is this important? It's important because when we break it apart, we need to notice that the numbers that when they multiply equal the last term, which we call the C, add up to the middle term, which we call the B. What that allows us to do is reverse that foiling process, and we call this factoring. You might say, that did not make sense at all. It will right now. I'm going to take that exact same problem that we foiled, and I'm going to factor it. What that means is when I did first, outside, inside, and last on this unknown multiplication problem, I got this answer. Well, the only way for me to get x squared out of those first terms is to do x times x. That's why it's important that we notice that this coefficient was 1. Because when we mess with that and make it, say, a 6, then we've got to decide if we do, say, 2 times 3 or 6 times 1. But when we lead in just an x squared, that decision is made for us, because the only way we can get that is x times x. Then what we do is we go to this last term, and we know that when I multiply these two, I got a 21. So there's only 2 things, 2 pairs that when multiplied equal a 21, a 7 and a 3, and a 21 times a 1. But it's really important to notice that whatever multiplies to equal the last has to add up to the middle. So when I talk about what's my winning pair, 7 plus 3 gives me a 10. So I choose a positive 7 and a positive 3. That process is called factoring. It's basically unfoiling. The beauty of it is you'll always know if you factored correctly because you can foil your answer. All right, so I'm going full circle here. let's FOIL this. First times first is x squared. Outside times outside is 3x. Inside times inside is 7x. And last times last is 21. These combine to give me 10x. You'll notice I get this back. Equivalently in elementary school, basically what I've told you is to maybe factor the number 12. And if you said, oh, it's 4 times 4. Well, when you do 4 times 4, you get 16. You don't get that original back. It means you need to adjust that. This is called factoring. We're doing the same thing, only on a polynomial scale. So let's flip the page here, if it'll flip. And notice that to factor, you must find two numbers that have a sum of B and a product of C. Again, basically that means they multiply to equal the last term, and they add to equal the middle term. So let's do a little practice. First of all, we do not need to worry about our firsts for a while. That's coming again in another lesson. We know that to get x squared, the only way we can do that is x times x. All right? We now need to multiply to equal 15. Well, again, our decision isn't too hard to make because we can only get a 15 out of 15 times 1 and 5 times 3. I need to decide which pair adds up to 8. Obviously, I would choose 5 and 3. You might say, what's this mean? This means B is bigger than 0, C is bigger than 0. So what this means is everything's positive. Those are the easiest kind because I can do both pluses. Again, how can I check my answer? I just FOIL it out. Again, basically what we're doing is unfoiling. We're figuring out what the first terms had to be to give us this x squared right here. What do the outside and the inside have to be so that they add up to 8x? And what do the lasts have to be so that they multiply to equal 15? And you'll notice these add up to 8. I'd like you to pause this and try the next one. So here I go. This came from first terms, which means I must lead in r times r. Go ahead and put that down. You're all set. Additionally, it helps me to notice that these signs are all positive, so I know I need two positives. That's going to be important later, that sign analysis of do I need two positives, two negatives, or one of each. When the entire polynomial is positive, we don't have much of a decision to make. Now, I need to make sure that when I do last times last, because again, this came from first, outside and inside combined, and last. They have to make a 24. Here's my options. I could do 2 times 12. Those multiply to equal 24. I could end in 4 times 6. Those multiply to equal to 24. I could end in 8 and 3. Those multiply to equal 24. Or 24 and 1. However, there's only one pair that's correct. How do you decide? You go right to the middle because they need to add to 11. Adds to 14, adds to 10, adds to 11, adds to 25. So my winning pair of last terms are 8 and 3. And you do it doesn't matter if you write it like this or like this. These are equivalent because multiplication order does not matter. So now what I'm going to do is very similar. I'm still going to lead in just an x squared. So we're not going to have to worry about those first terms. It's going to have to be x times x. The only thing I've done here is I've changed this to a negative. So what does that mean? Well, let's look. What's the sign of C? And again, by C, I mean this last one. This is A, which is 1. B is negative 11. C is 24. Its sign is positive. What is the sign of B? Negative. So kind of notice what that means. I need to multiply to equal positive and add to equal a negative. Well, if two numbers multiply to be positive, they're either plus plus or negative times a negative. But because we're adding to equal a negative, I know I have to have two negatives as my winning pair. So I'm going to rewrite this so you can see what I mean by that. Again, we're going to go through the same process. This comes from firsts, which can only be x and x. This 24 comes from the lasts, which we already did up here. Is it 6 and 4, 12, boom, boom. Which pair is it? And again, I'm choosing 8 and 3, but here's the difference. I have to have them both be negative so that they add up to a negative 11 here. Negative 8 plus negative 3 is negative 11. Now, how could I check it? Firsts, x squared, score, outside minus 3, inside down 8, and my lasts, a negative times a negative is a positive. And you'll notice that when I combine these, I take negative 3 x's and drop it 8 more, I'm at minus 11x. I must have factored it correctly. So this right here is called the factored form. I've broken one problem into a multiplication problem. So let's take a look. Next up at the top of the page, part A, it says, what is the factored form of y squared minus 6y plus 8? Well, first of all, let's get the stuff we know. We know the first have to be y and y. Next, let's do a little sign analysis. I multiply to equal a positive, which means either both positive or both negative. Because of this middle term, I know I've got to both be negative. Now, I just need to find that pair of numbers. Well, there's only two things that when multiplied equal an 8. 8 and 1, or 4 and 2. I need the pair that I can get that 6 out of. So I'm going to have to choose 4 and 2 with both being negative. Notice they multiply. Negative 4 times negative 2 gives me 8. Negative 4 plus negative 2 gives me a minus 6. And I have factored it. For part B, can I factor this? Well, let's take a look. Let's give it a try. X and X would have to be my leads. I know that because it ends in a positive, I've either got to go plus plus or minus minus. Because of the middle, I know I need to go minus minus. Well, let's take a look. The only things that multiply to equal 2 are 2 and 1. And I know they both have to be negative. But when I add those up, I get a negative 3. And keep in mind, I need to get this middle term. So my problem is, basically, I can't do it. You might say, well, what? How do they give me something that doesn't factor? Well, it's just like in elementary school when they say factor 13, you'd say, I can't, and there was a word for it. When you couldn't factor it, like 13, 7, 5, 19, 79, we called it prime. Well, this is called a prime polynomial. So let's go do some practicing. This one we already did, so it should look familiar. We chose 8 and 3. All the signs are positive, so we did that. I don't need to redo that one. Let's go do number 2 slowly. Let's go through the process nice and slow. I need to factor this. Basically, I need to unfoil it. This came from first. Outside and inside combined, this comes from lasts. The only way I can lead it to get x squared is to do x times x. That's a lock. Okay, got it. Next I go to the end here, and I think, well, how can I multiply these two to get a 24? And there's several ways. I could do 6 times 4. I could do 8 times 3. I could do 12 times 2. I could do 24 times 1. My goal is to get a pair that when added gives me a negative 9. 10, 11, 14, 25. There's no way to do that. So I say it's prime. Now most of the time these are going to work, but I want you to understand actually that there's just as many polynomials that aren't factorable as there are ones that are. So, we would call this prime. Let's go look at the next one. All right, the only way I could lead it is in x and x. Got it. I could end it in 6 and 2, 4 and 3, or 12 and 1. Those are my only options for ending this, because when I do last times last, I better get a 12. Is there a pair of these that adds up to 7? Here it is. And I know they're both positive because of the positive sign there. Let's try another one. How can I start this one? I can start it in x and x. How can I end this one? Well, for sure they have to have y's on them because of the y squared there. And the only way I can get a 2 is to do 2 and 1. Question is, do these add up to 3? And the answer is yes. All right, how about signs? Everything's positive, so I do a plus. Now, let's check this one. How? I FOIL it. So just a quick little check. That's the beauty of these, is you'll know if you ace it just by running a quick check on it. Oops, sorry. I've got a little problem here. I said 2 and 1, and I wrote 2 and 2. So let's go do a little check. First times first gives me x squared, 4. Outside gives me positive 2x y. Inside gives me a positive 1x y. And my last gives me a positive 2y squared. When I combine outside and inside, you'll notice I get 3xy. So I have factored it correctly. Do you have to check all of them? Not necessarily. But if you're not sure, when you actually ask me if your answer is right, I actually FOIL what you got. So I would suggest you check ones you're not 100% sure about. One more, number 5 here. Let's take x times x is the only way we can lead this one. The lead's not going to cause you a problem for a couple days. Also, let's take a look at signs. It ends in a positive, which means it must be something positive times positive or negative times negative. I challenge you to look carefully and decide which one it is. You're going to be looking at that. So negative, negative. That's the structure of my answer. Now I just need to figure out what do I put here. Well, two numbers that when multiplied equal 48. But at the same time, they have to add up to 16. So let's begin. What gives you a 48? 48 times 1 doesn't add up to 16. 2 24s doesn't add up to 16. Does 3 go into 48? If you remember your elementary school test, if they add up to something that when you divide it by 3, it comes out nice, 3 goes into it. You could use your calculator, but 3 goes into 48 16 times. Nope. Does 4 go into 48? Yes, 4 times 12. And then there's also 6 times 8, which gives us 48. These are all, I've got 5 ways I could end this problem. I've got 5 ways I can multiply to equal a 48, but only one of them adds up to 16. So that's my winning pair. All right, so I think I'm going to take this number 6 and I'm just going to make it a little nicer here. I don't like the double variables when we're first learning these, so I'm just going to have you change this to x squared plus 5x plus 6. Okay, so let's begin. How must I lead it? X, x, bam. First will give me x squared. Then I go to the end, because that's how I have to end these. And I have to multiply to equal 6. 6 times 1 or 2 times 3. I pick the pair that when added gives me a 5. So I end this in a 2 and a 3. I know I need either positive, positive, or negative, negative. This determines it. So plus, plus. And again, we could check all those answers by FOILing it. And that's the end of the lesson for today.